Interference, a guide for A-level students. Firstly, we need to talk about coherence. In a coherent light source, all of the light waves have the same frequency, phase, polarization, and direction of travel. A normal 60-watt light bulb doesn't harm anyone, but a 60-watt laser would easily cut through plastic. Because lasers are coherent light sources, they are also monochromatic, whereas a regular bulb has a range of wavelengths and colours which it emits and mix to become white light. This is why laser light is good to show interference and diffraction. If light passes through a double slit, everywhere except from the central maximum, the light from each slit will have travelled a different distance. We call this difference in the distance travelled by the light the path difference. This path difference leads to the interference pattern that is produced on the screen. We can look at the distance the light travels in terms of wavelengths. If there is a difference in the distance, there is a difference in the number of wavelengths the light has travelled. If the path difference is a round number of wavelengths, constructive interference occurs, as the light is in phase. If there is a half wavelength difference between the distances, destructive interference occurs, as the light is not in phase. This can be shown with the aid of this diagram. The top shows constructive interference. The maxima and minima line up. The wave that is output has the same wavelength but has double the amplitude. The bottom shows destructive interference. The maxima of one wave line up with the minima of the other wave, and so the waves cancel each other out. Let's talk about the double slit experiment, or Young's slit experiment. We start with the setup you see here. A coherent light source from which light travels through screen 1, which has 2 slits in it. It then passes over a distance and hits screen 2, which is our viewing screen, where we will see our interference pattern. If the brown lines are light waves, having travelled the same distance from a coherent source, they are in phase, so their amplitudes add, and a bright spot is seen on the screen. This is true for anywhere where the path difference is a round number of wavelengths. In contrast, these waves travel different distances, and the path difference is such that the waves are not in phase when they arrive at B, so the interference is not constructive. Now let's define some distances so that we can write an equation to describe our system. If we call the slit separation S, the distance between the screen with the slits in and the viewing screen D, the distance between the bright spots or dark spots Y, and the wavelength of the light lambda, we find the equation to describe our two-slit system is Y equals lambda D on S. This slide shows the standard interference pattern for a monochromatic coherent light source passing through a double slit and onto a screen. Thank you for listening.